Hey everybody, this is Larry. This is day 7 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button. Join me on Discord. Let me know what you think about today's poem. 1-3-2 pattern. 1, 2, 3, 4, 5, 6. That's not how the song goes. Anyway, weekend is here. Hope you're having a good day, good week. It's been a little rough week stock market wise for me, but I don't know. It is what it is. Hopefully things will bounce back, right? Yeah. Hope everyone's having a good weekend, and we'll see how it goes. All right, let's go on with today's poem. Today's poem is 1-3-2 pattern, such that IJK, then sequence one. Okay, so smallest, biggest, and a number. Okay, what does that mean? And we have to have only return true or false. Okay. Try to think whether. So for these kind of problems, there are two ways to do it, right? One is try to see if 1-3-2 pattern is in the array. The second way to do it is see if there's a way, or find the property such that this pattern is not in the array, and then see if that fits that pattern. Let's see. And I think my first intuition, and I don't know if this is right to be honest, is seeing whether, okay, we know that from this example that this is false, that if it is sorted, there's no there's none of this 1-3-2 pattern. But is it true that but you know, you have to prove both you have to prove to both the inverse and the contrapositive. Am I missing the inverse and the converse or something, right? So so I'm just trying to think whether, okay, if there's no 1-3-2, is it always a sorted pattern, right? So I think that's what I'm trying to think about trying to do. Try to see if I could have a proof there, right? Let's see. If there's a so if it's unsorted, let's say something is unsorted, does it always have a 1-3-2 bar? The answer is no, right? In that it can be reversely sorted, meaning 4-3-2-1. Do we have to check for that, and is that good? Like, is that just a special case where if it's sorted or opposite sorted, it's good? So I'm still having like some allergy related talking stuff, so if I'm talking a little bit funny, I've been with the allergies and my nasal and all that stuff. Human body is fascinating in a disgusting way, and also I don't know. Maybe I'm just getting old. But anyway, so then now yeah, let's say something that's nearly sorted. What does that mean, right? If this is nearly sorted, then well, this is 1-4-3, right? What does it mean to be nearly, or like? I mean, it could also just be not sorted, but what is the minimal out of orderness, right? So if something is out of order, I'm trying to rephrase it in a way that is consistent with this. So if something is out of order, okay. And another way that I'm thinking is that, okay, let's say we have this 1-3-2 pattern, right? Is there a way to make sure that, and this is part of the proof, because of course we can YOLO implement what we just talked about already and then submit and be like, proof by AC. But I'm trying to do a little bit better with respect to trying to see if I can at least like convince myself that it is good enough, right? Yeah, and one way that I'm thinking about now is proving that every unsorted every non-ascending array or non-decreasing array. Let me also see if the numbers are unique. The numbers are not unique. Does that change anything? It should be okay. I think that doesn't change anything. Okay. So basically, I'm trying to think whether, all possible unsorted array is just a version of this plus more numbers, right? So let's say we want to add, number here. Well, that's still 1-4-2. So then, okay, let's say we have this array, and we want to add a number that's smaller than 1, right? So if we add a number that's more than 1. This way it will still contain it. Or maybe another way to do it is, okay, let's say we have 2, 4, 6, right? And we try to add a new number that is not sorted. Like, I'm trying to see if I can add a number that's not sorted that doesn't create the 1, 3, 2 pattern, right? So what if I create one here? Does this have a 1, 3, 2 pattern? Actually, I guess this doesn't, right? So in that case, I mean, it has a 2, 3, 1 pattern, I think, right? No, this is because no, it has a 2, 1, 3 pattern, but it's not sorted. So okay, so I guess what we've done is find an example where there's no 1, 3, 2 pattern, but it is also unsorted. So okay, so I'm glad that we got that out there. That's not a 2, 3, 1 pattern. What is that? That is basically oh, okay, but maybe it does point to something, right? In that maybe this is just like descending and then increasing. Maybe when I said that it's going to be increasing or decreasing, that was in general enough. Maybe it just has to be almost like a peak of, okay, yeah, like it's ascending and then descending, right? So in a way, you could write this as, there's 2 ways to write this, I think. Just like you can reform or renormalize this to 1, 2, 3, 4, 5, 6, and then 5, 4, 3, 2, 1. Obviously, you can extend them more, but that would be the pattern that is not a 1, 3, 2 pattern that's also not sorted in either dimension. And then the other one that you can do is maybe 6, 5, 4, 3, 2, 1, 2, 3, 4, 5, 6, right? And then now the question is there something that isn't this pattern that is still one like if every pattern that doesn't have a 1, 3, 2 pattern is still in this way, and I think you could do some like proof by contradiction and adding every possible number. Like let's make a small example of 2, 4, 6, 4, 2, and let's say now we want to add a 1, right? Obviously, if we add a 1 in the beginning or the end, we still don't have a 1, 3, 2. But what if we add a number here, right? Does this have a 1, 3, 2? Also, did I lie? Because I think I'm lying. Because I think there's literally 1, 3, 2. So I'm wrong here. Wow. I'm just wrong a lot today. So I was just trying to figure out by generalizing, right? And obviously 1, 3, 2 is literally in the way, so that doesn't work. Huh. But if we have something like, if this gets cut off, this works, right? Okay. I think I'm trying too hard on this route, and I don't think this way is kind of like I don't think I could figure out something that's generalizing. Though this is 1, 3, 2 as well, 4, 6, 5. So maybe that doesn't work. Then what was my example before? This one? Is there 1, 3, 2 here? I think maybe I think maybe that's what I was doing. Maybe I was wrong here too. I looked at this. I was like, okay, this doesn't work. So maybe I generalized the symmetry version of it. But no, the symmetry is wrong because you can see that there's 1, 3, 2. But here, maybe I'm okay because there's no peak and going down. Yeah, right. So basically, anything that's a decreasing pattern, and then now we can maybe also do what we said about see if we can prove by contradiction and adding a 1 in random places. Obviously, if we add a 1 in the, where would we add a 1? So the only place that we can add is before the 2 or after the 2, but obviously it doesn't change the property. If we add it here, that'll be bad. If we had it here, is that bad? Oh man, allergies is really kicking my butt. But here it still doesn't have a 1, 3, 2, right? So maybe our generalization doesn't really our attempt to kind of make a better solution doesn't really hold up here. So maybe we can just think about, processing from left to right, some technique like that. I think I definitely, my apologies if it feels like I'm wasting your time, because I feel like I was trying to see if that really worked, but clearly it doesn't. So I'm exploring maybe another way. And this is what you need to do in contests sometimes, is that, I think, and this is very hard for me as well, and that's the hardest thing, is that you know that maybe you're making progress, and as you saw what I did, I was making progress, but sometimes you just have to restart from scratch, and then go, okay, what can I do, right? Okay, so for every number here, I think we just try to get the minimum number from the left, and then, because anything that's minimum would be fine, and in a greedy kind of way, right? So going from left to right, let's say we assume that the current number is the 3. What does that mean, right? Oh, do we? No, I guess this is now a smarter number way, and now I feel really dumb for wasting a long time, because now we just assume every number is the 2 in the sequence, right? Then now we ask ourselves, for this number, is there a number before us that's smaller, and is there a number before us that's bigger? And that's it. Sometimes these kind of things happen, right? So yeah, so let's go. So min is equal to, say, infinity. And then max is equal to max is equal to negative infinity. And then now you go for x in nums. Okay, first of all, if there's a number that's smaller than this number and there's a number that's bigger than this number, then we return true, right? Otherwise, we just update min is equal to min of x. Oh man, this is much easier, clearly, but well, if I could type it out. But that took a while, and that's a little sad. If we go through all the way, then we should be good. Actually, this is easy now that I think about it. Well, I guess that's the thing with these problems, is that if you think about it correctly, it's easy, but if you don't, then it's hard. And we spend a long time doing it just for us to solve it in 10 minutes, or in less than in 2 minutes, basically. I guess that's why you kind of need to reset and stuff like that. So let's see if that works. Oh no, did I misunderstood something? And maybe I'm still wrong, clearly. Let's see. Why was I returning false? Was I returning false? So I was returning true when the expected answer is false. What is the 142 here? -4. Oh no, x is -3. Did I say that in the wrong way? Oh, wow. Today I'm really off, ain't I? Because basically, okay, I generalized a little bit too quickly without thinking through it. Basically, this is a 3-1-2 pattern and not a 1-3-2 pattern. So we could do both, then it's fine. But in this case, that's not the case. So that's why we need to do we have to be the 3 in the middle so that we can enforce the ordering. So okay, let me restart again from scratch. Now that wow, this is kind of embarrassing. Hope y'all are having a good Friday. I'm having a kind of a rough Friday on what is supposed to be probably a straightforward problem, but I'm having issues. But okay, so then now how do we want to do it, right? Well, just giving a number, because I mean I knew how to do it, but I thought I could simplify it, and that's, I guess, part of sometimes you try to prematurely optimize, and in this case that is what I did, and that is leading to be a sad times. So there are a couple of ways I can think about it. So first of all, we conceptualize what our question to answer it in a way that we can do it number per number, right? And the thing I had to do is that for each number, let's assume that this is the middle number, the 3 number. Then the question is, okay, given a number that we're going from left to right about, is there a number to the left that's smaller than the number that's to the right? Both numbers smaller than this current number, right? And that's basically what we need to do. And the way that we can do this here is we ask ourselves another question of, okay, given that we're the 3, give me the smallest number to the left because, well, that's easy, right? Because in a greedy kind of way, we just want the smallest number that's going to be smaller than 3 and hopefully smaller than 2. And also in that way, we want a greedy kind of thing for the number to the right, right? We want the largest number that is smaller than this number, right? And there are a couple of ways you can do it. You can do it in a linear way with probably monostack. And man, I can't really talk that much. My allergies is just killing me, and you can see me rub my eyes a lot, which is actually a bad sign. But yeah, but that's basically it. So let's get to it. I prematurely optimized and got it wrong. So yeah, so basically, going from left to right. So there are 2 things we can do. So let's look at the prefix min. So that we do the prefix and then the suffix query independently. Prefix min. So let's say it's going to be start with infinity, and then for x in nums, prefix we append the prefix min of the last number, or this new number, right? And then now we have the prefix min, and then now we want to go backwards. Yeah, let's just create an extra array so that I don't have to do it in order. And then now for x in reverse order, what are we doing? Basically now we want to get the largest number that is smaller than this number, right? So what does that mean? And this is going to require probably some mono, I think it's a mono stack, but and you can actually implement this using like a sorted list or something and a binary search, but I'm trying to, and in contest time, that's probably what I would do. But right now, I'm trying to do it in a linear time way, and which is why I have the extra constraint. Hope that makes sense. And then, yeah. And basically, so the first number is going to be 0 or infinity because, yeah, it's just infinity. So then now, if is greater than 0 and the stack. So let's say this number is bigger than this number. What does this mean, right? If it's bigger than this number, then no, do I want to get rid of it? Because then now if I get a bigger number in the future, I actually just want the biggest number that's, it doesn't have to be next to it. I think that, okay, I think that's why I'm confusing a little bit. It could be just any number. So yeah, so actually maybe I take it back. Let's just use also like I'm struggling a little bit like physically. So let's just use a sorted list, and then sorted list we add x well afterwards, but before that we want to search we want to search for the smallest number that is bigger than, or the biggest number that's smaller than this number. So that's going to be this, and then we go backwards, and then we just reverse the array so that we Yeah, else. And then now we can take a look at the prefix and the suffix together. Man. Sorry, friends at home. I'm clearly, the allergies is really getting to me with respect to speaking. Like I could still think okay. Actually, maybe not because, because you know, but that should be okay. So what this is saying is, for 0, oh no, this is the different input. So for -3, there's no smaller number to the right. -4, there's no smaller number to the right. 1, the next smaller number is -3. So that's what I have here, okay. And 0, the next smaller number is -3. So, okay. So then now, the thing to do is now for 3 in, I may be off by 1 here. No, let me double check. Should be okay, yeah. So the 1 refers to the first one, and yeah, okay. I just have to make sure I get my indexes right. Nums. Basically, we skip the first number in the prefix and the last number, and then map it to that. So if now, if in the prefix, if the number before the smallest number to the left is smaller than this number, and the number to the right, oh wait, I think all we have to do is this. Then return true. Otherwise, return false. We run it real quick. Allergies is really affecting me. Hopefully, I'm good by tomorrow. But I just return true for everything. Okay. Why is that? Maybe I don't have my arrays alignment correctly. Oh no. Okay. Well, if infinity is in there, that's always going to be true. Do I want it to be infinity or negative infinity on suffix? Yeah, let's make it negative infinity because, yeah, that makes more sense because that is going to be the next number that's smaller than it. Okay, so that looks good for here. I'm a little bit tired, so let's give it a submit. But usually I would test more cases. Hopefully this is right. Okay, cool. Clearly not the best answer. Let's see what I did 2 years ago. I think this is probably some 4. Oh, okay. Wow. So there is a monostack solution. Yeah, so the answer is that there's a monostack solution. I'm not gonna lie. This is kind of disappointing for me. Like today is just a little bit off. But that said, I still solve it. Though the timing is just terrible. But you know, like I said, I still solve it. So sometimes, you know, like I always say, if your bad days, you know, if you're still okay on your bad days, then, you know, your average days will be much better. And that's where practice comes in. And there's more than one way to solve it. That said, I'm just, I know how this works now, but I did not remember this. So, yeah, the idea is that we keep track of the smallest number to the left and the biggest number to the left, and kind of keep track of the min and max. I think I definitely have a video for this one, so I'm just gonna have a link below. My apologies for having a whatever today. Today's I guess I'm not super recovered from yesterday's sickness, so yeah, I was hoping I was, but I could barely talk anymore. So I'll just link to that. If I remember correctly, this still took me quite a bit of time. So check that out and let me know what you think. I'll put a link in the comments and the description. I'll see you later, hopefully. I'll feel a little bit better. But stay good, stay healthy, to good mental health. I'll see you later. Take care. Bye bye.